Hi, I'm Michael Baddeley, and I'm a senior research engineer with Toshiba's Bristol Research and Innovation Lab. I'd firstly like to thank you all for joining this talk virtually. Obviously, we cannot be here in person, and this actually leads me into the topic of this presentation, which is on the importance of remote testbeds and looking at how the restrictions and societal changes resulting from COVID make them so important going forward, not only for our own work as researchers, but also for teaching and as a tool for virtual collaboration. So we'll be splitting this presentation into 4 parts. We'll firstly look at how the global COVID-19 pandemic has almost overnight radically changed how and where we work, and the knock-on effect this has had on academia and teaching. In particular, what does this mean for research communities that rely on experimental hardware? My own personal background is very much in low-power wireless networks, so I'll give a brief overview of some of the remote testbeds that are popular within the community, and where practical experimentation plays a vital part of our research. I'm then going to introduce a 200-node multi-radio testbed that Toshiba is deploying across a number of sites in Bristol in partnership with local council. And then finally, I'll cover how the restrictions imposed on us by COVID emphasize just how important remote testbeds and remote experimentation will be for both teaching and academic research going forward. So firstly, let's take a look at how COVID-19 has changed the way that we work, the way that we teach, the way that we live, and what does this new normal mean for us going forward, hopefully post-COVID. So although we're now many months after lockdown restrictions were imposed, depending on where you live, many of us are actually still working remotely. The social distancing measures that forced this issue meant that it was a scramble amongst businesses and universities to figure out how to make remote working and teaching possible. And to a large extent, this actually been pretty successful. However, this has also resulted in a lot of people realizing that offices are pretty rubbish places to spend almost a third of your life, and many people just don't want to return. This unwillingness to return to the office is particularly noticeable in English-speaking regions, where even though Boris Johnson says it's safe, for some reason we just don't believe him. For some people, this isn't even a luxury, but necessity. For example, those who have to self-isolate or shelter. Of course, while many people don't want to return to the office, there are certain jobs, like frontline workers, who can't work remotely. Many others are also beginning to realize that the children are just tiny little psychopaths who can't be trusted in their expensive equipment, and at the end of the day, the home just isn't an office and isn't set up with the same facilities. On top of all this, remote teaching makes it particularly hard for universities to justify the quality and value of degrees where lab work plays a big role. All this means we need to ask ourselves, what does this new normal mean for us as researchers? As I mentioned, my background is very much in low-power wireless. As a low-power wireless researcher, this means a lot of my work involves writing code for and experimenting on hardware devices. And these sorts of networking setups can be incredibly complex, with dozens to hundreds of devices in a single setup, such as the dense network deployment that we have at Toshiba, which you can see there on the right of the slide. Now, when lockdown started, we were pretty lucky. We had already set up remote tools to maintain our internal testbeds and remote services to use them. Now, at first, this was awesome, and everything was working a treat. But then, around about June time, the students came. And what you see here is a map of our internal testbed in Toshiba Bristol, where in March, at the start of lockdown, we have 21 nodes scattered across multiple floors in 2 buildings of the office. All's well and good, and everything is working. However, in June, the students arrive. Some projects needed equipment, and so people started to help themselves to stuff lying around the lab. Perhaps they thought, oh, no one is in the office, that must mean they aren't using it. But for whatever the reason, our 21 nodes were suddenly reduced to 11. A few months later, and while we could get by on just 11 nodes, we redecorate next door, and all of a sudden 3 more nodes are gone, along with the Pis they're connected to. This leaves some of the nodes completely orphaned, and what's worse is this is one of the interesting ones, is located through a building wall and 2 floors. So what did we learn from this experience? First of all, students are the worst, with nobody around to actively maintain the testbed or physically stop people stealing nodes. The testbed has largely been cannibalized for other projects. Sure, we can rebuild it, but it shows just how much time, effort, and constant monitoring a remote testbed needs in order to keep it running smoothly. In the beginning, however, it was easy to perform experiments, easier to log and analyze data, and most importantly, it allowed us to do this from home during the height of lockdown. Right, so I mentioned earlier that the low-power wireless community has quite a lot of experience designing, building, and maintaining remote testbeds. Specifically, if you look at a random paper from a researcher within the community, you'll likely see one of the following testbeds mentioned. You have DCube at TU Graz, which has been the testbed of choice for the EWSN wireless mesh dependability competition over the last few years. There's FIT IoT Lab, which is absolutely huge and uniquely covers multiple sites across France with thousands of nodes. There's Indra 2 at the National University of Singapore, which is derived from the old MoteLab testbeds and has recently been updated with modern wireless platforms. And then finally, there's FlockLab 2, which coincidentally you're actually going to hear about from the next speaker after this talk. And if you've ever used one or more of these examples, you'll know that they have a bunch of things in common. Firstly, they all provide open access environments and tools that allow even non-expert users, such as the aforementioned horrible students, to quickly program devices with their own solutions. To a greater or lesser degree, they all provide standard use cases and scenarios, like set layouts and data patterns, that allow a user to compare results against previous jobs and benchmark their solutions against others. They also acknowledge that a testbed just can't sit there and gather dust, but should be upgraded as and when is needed. DCube, for example, recently added the increasingly popular NRF 52840, while Indra and FlockLab have similarly benefited from recent upgrades. And finally, they incorporate architectures that make it easier to maintain and scale the testbed. In particular, FIT IoT maintains many hundreds of nodes across multiple sites, which is something that Toshiba took inspiration from and brings me nicely to the design of our own multi-radio outdoor testbed. So Toshiba's Umbrella IoT Testbed is a joint project in partnership with South Gloucestershire Council, where we aim to deploy over 200 outdoor multi-radio IoT nodes at a number of sites across Bristol. The idea was to develop multi-purpose and modular nodes alongside a fully integrated back-end system, capable of satisfying a number of use cases and different stakeholders on a single unified platform. In this first phase of development, this means we're focusing on open city sensing, i.e. what council, businesses, and academia can do with various types of sensor data. Secondly, an experimental wireless testbed similar to the ones I just mentioned. And thirdly, a warehouse robotics testbed where mobile robotic nodes can be programmed remotely for experimentation. Incidentally, this is something that FIT IoT Lab also has. Again, all of these use cases will use different configurations of the same hardware and software stack, and they'll be able to be fully integrated with the same back-end system. The nodes are grouped into separate testbed sites according to each use case, with one of the sites being a testbed corridor nodes mounted on lampposts along a dual carriageway near the University of West England, or UWE, in North Bristol. These nodes are powered from the lampposts themselves, and with every other node supporting a fibre connection. As I said, one of the core ideas behind the design of Umbrella was to support modularity and a unified hardware system, whatever the use case. This was particularly important to us because although I've mentioned those 3 specific use cases that we're looking at, I think we've identified maybe another dozen or so that could be incorporated into future phases. I apologize for the terrible picture of one of the completed nodes on the right of the slide there, but essentially the large rhombuses hold the main board, power circuits, and edge processing unit, while the modularity comes from the sensor and radio hats that can be attached to the smaller child boards at the bottom. Incidentally, early in the project we also made a prototype remote version of these child boards that can run off battery, which we intended mainly for remote use cases, but this still exists within the same hardware and software platform of the full Umbrella node. One of the challenges we identified early on, and this is a huge challenge for any remote testbed that is mainly deployed outdoors, is how do you make the nodes unbrickable? This isn't really unique to Umbrella in particular, but the move from an indoor scenario to an outdoor scenario means that all of a sudden you're installing these nodes at locations you don't own, you need permission for, and each time you want to fix a node, you need to pay a considerable sum to scale a 20-foot lamppost with a cherry picker. Alongside a number of software and hardware decisions, our solution was to make the node accessible through fiber, through Wi-Fi mesh, and as a backup to backups, 4G cellular. All nodes support Wi-Fi mesh from the mainboard and automatically try to join the nearest fiber supporting node. In the dual carriageway deployment I talked about a couple of slides ago, I think something like every second node is a fiber node. Once it has either a Wi-Fi or a fiber connection, the node will automatically attempt to join the backend systems through the VPN that connects all sites. So we were actually meant to start deployment a little earlier in the year, but then lockdown happened, which pushed things back a bit. However, we've now started the first deployment outside the university campus, and as you can see, my colleagues chose a pretty nice day to do this. So, given what I've said so far, and Toshiba's own experiences with deploying a fairly extensive and complex testbed during the middle of a global pandemic, what are the challenges and opportunities for remote testbeds and experimentation, given this new normal has completely changed the way we live and work going forward? Some of the challenges are the same as they've always been. As we discovered with Umbrella, deploying an outdoor testbed is an insanely complicated process that brings a lot of headaches. Planning permission in particular is a huge issue. For example, the fiber nodes, we actually had to dig up roads in order to install the cabling. All this requires time, money, and is extremely difficult to get people to agree to this. You also need to think about precisely where you want to deploy your equipment and how you can do this safely. Again, this costs time and money, and it needs to be done properly. Weirdly, you also need to be aware of the tinfoil hat brigade. Particularly since companies started to roll out 5G masts, conspiracy theorists have had a field day. Also, outdoor testbeds inevitably need to survive all weather conditions, and putting electrical equipment into a small confined box brings all manner of challenges related to temperature and precipitation. Although not so much of an issue when your devices are on top of a lamppost, there's a very real risk of people trying to tamper with the equipment, particularly in city centres on a Saturday night, for example. And finally, specifically in outdoor environments, your nice, cozy Raspberry Pi box runs a very real risk of being home to actual bugs. It's so ridiculous, but these are things that need to be considered during design and not once you've installed it up said lamppost. So the impact of COVID on all these challenges is just that it makes it just so much harder. Our initial deployment was delayed due to lockdown restrictions causing massive delays to hardware orders, issues with trying to get people on site to physically install nodes, and even in the office, we need to consider social distancing safety issues and make many remote decisions. Of course, one of the true constants is the British weather, which remains the same. And when I was doing some range testing the other week, I didn't get the lovely sunny day my colleagues got back in April and May. However, and I think it's important to note this, post-COVID there will also be opportunities. And I think that as researchers in the low-power wireless community, we're ideally placed to take advantage of our experience and knowledge of remote testbed systems. And I think this includes many, if not most of you here at IoTBench. Firstly, unlike other areas of academia, the fact that we have these publicly available remote facilities can help us to overcome some of the social restrictions resulting from COVID, in particular in delivering remote teaching and doing remote research. Secondly, I think these restrictions will force new and innovative remote testbed setups. There was actually an article in the BBC the other day about a remote laser testbed that's being developed at the University of Sussex in response to working from home conditions. And I think it's this sort of thinking about what can I turn into a remote testbed, which is where our community can really apply know-how and experience. Thirdly, by making our testbeds remotely accessible, it's far easier to foster collaboration with partner institutions and colleagues. Actually, at the start of lockdown, I started a collaboration with the guys at D-Cube, and for me personally, this has been a huge success, and we've generated some great research together, all the while being in separate countries and working completely remotely. And finally, it just makes life easier. This is a picture of my working from home setup that I put together in my living room just after lockdown. And because of the remote testing and experimentation, I've had access to all the systems, hardware, and resources that I need to do my research. This just wouldn't have been possible without the sorts of remote facilities. And that's the end of my talk. Thanks for listening, and I hope you've enjoyed it. If you have any questions, feel free to ask me just now or email me later.